Hello, students. I hope everything goes well. Now, I told you in the video before that I should do the squeeze theorem here, and let we do with help of an example with an example. And I have a function, that is the g of x, that is 3 minus the sine of 1 divided by x times x squared. And I have to look, or I have to prove that the limit from x going to 0 of g, that it exists, and also to calculate it. So I have to look if this exists, and I have to calculate it. Now, what can I do? First of all, I look at that function and I see the sine of 1 divided by x, and I know that for every value you fill in of the sine, that you always get a value less or equal to 1. So you know that that function is bounded, and maybe this one near 0, it is going very often between -1 and 1, but maybe that doesn't matter. We know that the absolute value is less or equal to 1, so that's okay. Then, what could we do? Maybe we can do the following. If you have there 0, and you have here the function g, and and if we calculate a lot of values of g, I think it will be a little bit going on this way. Now and then I think here near 0 it will go very often up and down, and farther away it will be going less than that, but okay. And I think also that it will go down if x is very great and x squared is very negative. So I think something like this. This will be almost the graph of g of x. Now, I have to take the limit to from x going to 0. So I have some area here around 0. There I have to look. And what goes further on doesn't matter me, only the area near 0. And then I am asking myself if I can find an upper boundary and a lower boundary. So can I find something from some upper boundary like this one here, and some other one, some lower boundary. And then maybe if these functions are in certain sense easy to do, and then if your function g is between those easy functions, maybe we can then also calculate the limit of that function. Now, I think that we can take for the upper limit, we can take 3 plus x squared. If you have constantly the sine of 1 over x, if that should be -1, then we have 3 plus x squared. I think this is a nice upper boundary. That we call that the h of x. And for the lower boundary, that we take 3 minus x squared. Now, and your g is there between. Now, and what now? Now we can calculate the limit for x going to 0 of that lower bound, and that is the limit from x going to 0 of 3 minus x squared, and I see that I get not 0, sorry, that I get 3 out of it. And I get of the upper limit, I get the limit from x going to 0 of 3 plus x squared, I get also 3. I see that those limits are equal, from the upper and lower boundary are equal. Your g is between that upper and lower limit, so we can conclude that the limit from x going to 0 of the g of x is equal to 3. Yeah, your g is between that upper limit and the lower limit. The upper limit goes to 3, the lower limit goes to 3, and so the function itself has to go to 3, and we have our limit. Now that is the, in certain sense, the squeeze theorem. So if you can find upper boundary, a lower boundary which have the same limit, and your f is between, then you also know your limit of your original function which you are which you have to calculate. So yeah, so you have, so if your g of x, no, sorry, your f of x is smaller or equal the g of x, and that less or equal the h of x, if the limit from x going to a of the f of x is equal to the limit from x going to a of the upper limit, now then we see that the limit from x going to a of the g of x has to be equal to L. Now, and there, this is your, that is the theorem, that is your squeeze theorem. Now, and so you can often calculate limits of very difficult functions by using, yeah, relative easy upper and lower boundaries. And yeah, okay, and then you can find your limits without any problem. Okay. Then I go to chapter 1.3, and then first of all, we never work with infinity. So so never work with infinity. So 1 divided by infinity, in certain sense, I have no idea what is meant. Yeah, infinity, a number in infinity is greater than every known number. That is infinity. That's such a definition of infinity. And so, so what? Yeah, what 1 by infinity? There is in some sense meant the following: that you take the limit from r going to infinity of 1 divided by r. That is, and that gives you 1 divided by a very great number, and that gives you 0. But this, yeah, in certain sense, I don't know what is meant. So be careful. So if you see such an expression here, keep in mind that you have some limit. Yes, and sometimes, yeah, that you see here greater than every known number. Yeah, if you are working in Zurich, the where you have that, I don't know how you call it directly. I'm searching. I have the name forgotten. The particle accelerator. Now, if you are working there, then maybe one is already infinity. If you are running, I don't know if a lot of students are doing that, but myself, I'm doing it. What do I find infinity? Now, at this moment, 30, 35 kilometers is for me infinity. Not really infinity. I should like to run more than that, but when I'm Sunday morning I'm running, then I think that if I have 35 40 kilometers I like to run, but maybe this is for me infinity. But but if you but 5 kilometers, yeah, is for me not infinity. But for other runners, 5 kilometers already infinity. Then they think, please, I don't want to run more than that. This is enough for me. And so you see that you have all kind of infinities, and for everybody can be infinity but something else. But one thing, therefore, greater than every known number. Okay. If you have to calculate such a limit, for instance, the limit from x going to infinity from x divided by x squared plus 1. Now, yes, what to do? You see your x is positive, and well, what can you do then? In this case, I think you can take some x out of the square root, and I get the limit from x going to infinity of x divided by x, and then a 1 plus 1 divided by the squared by x squared. So I have this expression here, and then I see that I have the same values here, so they can now, and your x is positive, so they fall away to each other. You get 1 out of it. This term, if your x becomes very great, it goes to 0. So you have there 0, and you get here out of it 1, just 1. But be careful. We can also do the limit from x going to minus infinity of the same expression here. And what then? And then be careful, because if you want to take that x squared outside the brackets, or outside the square root, I should say do that, but keep in mind that the square root of x is always the absolute value of x. Be careful here. So this is of importance. And so what do we have here then? Now you have your x and you want to have x outside the square, so that you get the absolute value of x times x1 plus 1 divided by x squared and taking the square root of it. And then look what happens. Your x is smaller than 0. You go with your x to minus infinity. So your x is negative. And that means that the absolute value of x becomes minus x. And so we have here the limit from x going to minus infinity of minus 1 divided by that square root. And your x and your absolute value of x, if you divide them to each other, you get minus 1 out of it. And you see, if the x goes to infinity, minus infinity, your x squares go to infinity. This term goes to 0, and we get out as the answer of this limit, we get minus 1. I will shift everything a little bit, so then we have enough space to write down the limit, so I get minus 1 out of it. Okay, now, and so we have calculated limits. So you can calculate limits. Never say that the limit from x going to a of fx is infinity or something like that. Please don't do that. And if this is the case, if fx becomes very great, then we say the limit does not exist. This is the good one. So be careful. So we are not calculating with infinities. We are not calculating with infinity. If you are in France, then some universities are calculating limits, but then you have to write all kind of rules for your infinity. For instance, what is 0 times infinity? Because what can be the case? Now the 0 maybe that is something of the limit from x going to infinity of 1 divided by x squared. the infinity. What can that be? That can be the limit from x going to infinity of x. And if I now multiply these things, now I get the limit from x going to infinity of x divided by x squared. And okay, now you can say you get 0 out of it. But what the other way around, you can also say 0 is the limit from x going to infinity of 1 divided by x. Infinity is the limit from x going to infinity of x squared. And what is then 0 times infinity? Now if we use the same rules, we get the limit from x going to infinity of x squared divided by x. And that gives you, what gives you that? So be careful. And for the same, you can have 1 divided by x and x, and you get 1 out of it. So be careful. We don't calculate with infinity. So never say that your limit is infinity or something like that. No, then we say it does not exist. Be careful. What shall we do? I think on this page just before I've already given some examples, and that has to do with the powers of x. And you see here, x to the power 1, here you see x to the power 1, and you see that you have the difference in those powers give you difference of your results of your function. Now, be careful by the calculations. For instance, limit from x going to infinity of x squared minus x plus 3 divided by 3x squared plus 5. Now, first of all, I look to the powers, and then x goes to infinity, and that means that these with the squares, x squares, that are the greatest terms of your nominator and denominator, the greatest terms. Then you see they have the same power. Okay, now what can we do? We can then divide them out. So we can write here the limit from x going to infinity. You divide x squared out of it, so you have 1 minus 1 over x plus 3 divided by x squared. And here we have x squared times 3 plus 5 divided by x squared. And what do we see? Those are falling away to each other. And these terms where you are dividing by x and by x squared, if the x goes to infinity, they goes to 0. And we see that we get out of it the limit, we get out of it 1 over 3. And so you see that you, in this case, if the x goes to infinity, you take the greatest terms of your nominator and your denominator, get it out of your expression, try to get it, if they fall away to each other, okay, and then you take the limit of the function you have. So, no problem. Another one, limit x going to infinity of 5x plus 2 divided by x to the 2 times x to the power 3 minus 1. Now, also, what to do? Now, look to the numerator and the denominator. Take the greatest power out of it. I see here that the x is the greatest one. And from the denominator, I see x to the power of 3 is the greatest one. If x goes to infinity, x to the power of 3 becomes greater and greater and greater. So what can I do? I can divide them out. So I have here the limit from x going to infinity, x times 5 plus 2 divided by x, and below I get x to the power of 3 times 2 minus 1 divided by x to the power of 3. Now, what happens? We can write it again. I look to this term here and I see I have 1 divided by x squared, and the other one I just keep it as it is and no problems. I am not dividing by 0 or something like that, and no problems at all. And so let x go to infinity. What do you see? The 2 divided by x goes to 0. The 1 divided by x to the power of 3 goes to 0. So this expression here goes to 5 divided by 2. That's the limit. And then we look to this expression here, and I see if the x goes to 0, you get 0. And so we have here, in certain sense, you can use those rules of the which we have seen in the other chapter, that you get 0 times 5 divided by 2. So it says that you have 0 times 5 divided, and that gives you 0. No problems. So always look to the greatest term, get that out of your expressions, and then see what you can do with it. Another one, the limit from x going to infinity, and then we subtract two things, and then I want to know what I get out of this. Now, first of all, if I look to it, I see that this one looks, if the x becomes very great, then the x squared is the term which is very big, and that is almost x, and I am subtracting something with x. Should I get 0 out of it? No, I don't know. So now I dare maybe 0, but I don't know. Maybe a wrong idea. Now, how to do this one here? I want to get such kind of expression as we have already seen. I want to have some things I can put away to each other, and then I want to have some constant. So what can I do here? Now, to make it a little bit nicer, I can do the following. I take the expression I have, and then I multiply by the square root of that expression, and then not minus but plus x, and I divide with the same expression. And so I say often, I multiply by 1. That is a certain sense what I do, but a special one. And now, what happens if I work out? What do I get? And that I will do on the next page, because I have not so much space. What do I have then? I have a minus b times a plus b. We know a squared minus b squared. And so what do we have here? Here we get x squared plus x, and then we have minus x squared divided by, and then we have the denominator, that was the square root of x squared plus x. And then I have to go further on to see what happens. I see here x squared and there x squared, they fall away to each other. And so I keep x in the numerator. So that here I keep x in the numerator. And then below, now your x goes to infinity, so your x is positive, and that means that if you look to what is staying behind the square root, you can take an x outside the brackets and you get the absolute value of x times, and then we have 1 plus 1 divided by x plus x. And we have here that we get here x divided by, now the absolute value of x is then equal to x, and so we have x divided by x, and then we have an expression 1 plus 1 divided by x, taking the square root of it, plus 1. Yeah, I see here that the absolute value, I see here my x, and that I have got outside the brackets. And so I get here that I have 1 divided by 1 plus the square root of this one plus x. Now, so we have a little bit calculated, and so the limit which is asked, the limit from x going to infinity of x squared plus x minus x becomes equal to the limit from x going to infinity, and then we have that expression we have just calculated, this expression here. And then I see that the x goes to infinity, so this term here goes to 0. And what do I get out of it? I get out of it 1 divided by 1 plus 1, and that is equal to 1 over 2. And I see that is not 0. Be careful. It looks... And so my idea was wrong. No, and so you have also to do all those limits. Be careful. And if a limit does not exist, then if you think a limit goes to infinity or minus infinity, then you say the limit does not exist. The limit from x going to infinity of x to the power 3 plus 1 divided by x squared plus 1. Now look to the numerator, and what do you see in the numerator? This term is the grows the fastest one, which this one becomes the greatest of the numerator. The denominator you have the x squared is the greatest of them, and you see that the power of x, the power of in the numerator you have x to the power of 3, so the power is larger than the power of the denominator, the x squared, and so if you divide them you get x out of it, and so I think the limit will not exist. But let me make it hard. So we take x to the power of 3 out of the numerator, so we have 1 plus 1 divided by x to the power of 3. And here below we take the x squared out of the numerator of the denominator, and I have this expression here, and I see that I have the limit from x going to infinity from x times that expression here. Now that last expression, that is just finite. So this expression here, that goes to 1 if the x goes to infinity. But you have here this one will be growing and growing and growing. That will then go to infinity, and so limit does not exist. That we will give as an answer, and we will not give infinity or something like that. No, here the limit not exists. That expression goes to infinity, so we don't have it. No. And then at the end of chapter 1.3 you have all kind of examples of where you are dividing, you have rational functions and what to do. Now read that very careful. Okay, now I just a little bit too much time for the video, so I will stop here with the video, otherwise I get problems.